Okay, so in intermediate algebra, we did 6.1, which was features of rational expressions. Now we need to be able to do operations with rationals. So as a reminder, when you multiply two fractions, you can multiply across the numerator and the denominator and clean up, or you can clean up first, but they have to be in opposites. For example, 3 over 6 can reduce to 1 over 2, so you can clean up before multiplying. I always suggest cleaning up before multiplying. I think it makes it easier. The reason for that is it's easier to make some numbers smaller and then make them bigger afterwards than it is to make numbers really big and then have to make them smaller after. For dividing, it's exactly the same as multiplying, only you keep the first fraction and you turn, when you're dividing by a fraction, you will really multiply by the reciprocal. So it multiplies by the secondary fraction, and then it's the exact same strategy. So let's see what this looks like in action with some variables. So as an example, how does this look like with rationals? If we have an x plus y in the numerator here and an x plus y in the denominator here, eventually they'll cancel. When we multiply them across, we have 2x minus y's in the denominator. One pair can cancel. Not both of them, but one pair can cancel. A pair of x's can cancel from the x squared over x. And what you're left with is your simplified answer, if you can't do anything else. So let's look at what happens here. You can clean it up without putting it all in one fraction. I can look at m squared divided by m. Now one of the m's will go away to reduce the m in the denominator. That leaves only 1 up here. Furthermore, 14 divided by 7 can reduce to 2 over 1. 10 divided by 15 can reduce by 5 to 2 over 3. So here we've got 2m over 1 times 2 over 3. When we multiply across, we get 4m over 3. Now, what would have happened if we didn't do that and we just multiplied first? If I had just multiplied first, 10m squared over 7 times 14 over 15m, I would have gotten 140m squared over 105m. Here, I realized the m reduces, and 140 over 105 reduced by a factor of 35 to 4m over 3. So this is why we recommend doing it the first way. It's just easier to see the numbers when they're 14 and 7 instead of when they are 140 and 105. Now, x minus y squared over 2 times 24 over 3 divided by x minus y. So first off, 24 over 3 in this side of the fraction can reduce to 8 over 1. Now, 8 divided by 2 is really 4 over 1. If we look here, this has 2x minus y's. This has 1x minus y. So we can cancel 1 and reduce this to a power of 1. So when we're done, we've got x minus y over 1 times 4 over 1, which we don't need the over 1s in this case. This is 4 times x minus y. Okay, what if it's not factored for us and we've got to do some work ourselves? 3 over 2y minus 6 divided by 6 over y minus 3. Okay, so for division, we turn it into multiplication by keeping the first fraction, switching it to multiplication, and flipping. You guys probably have heard keep, change, flip before. Flipping the second one. Now this is not factored here, so I need to factor. This is 3 over 2 times y minus 3 times y minus 3 over 6. And we can put this in parentheses if we want to. If we see these two y minus 3's, they will cancel. 3 over 6 reduces to 1 over 2. So in total, this thing is 1/2 times 1/2, which is 1/4. Again, let's look at the one on the right. X minus 3 squared over 6x divided by x minus 3 over 2. Again, keep the first fraction. Change to multiplication and flip the second fraction. I see two x's, an x squared here and an x. To divide them, the x's cancel, but this goes to the first power because there were 2. Same thing with the x minus 3's. This cancels. This goes to a first power. Multiply across. I get x minus 3 times x over 6 times 1, which I would write as x squared minus 3x all over 6. I think you can multiply out. There's an argument for not doing it in case you're trying to clean up further, but I think you can always multiply out as well. Okay, so now some larger ones. I'm going to do probably 5 and 7. So this is 5 is division, so this is 4 over m minus 2 times 2 minus m over 16. So this here is a rule we learned. These are opposites. And remember, opposites can reduce to negative 1 over 1. 4 over 16 reduces to 1/4. This is 1 over 1 times negative 1 over 4, which is negative 1/4. Now number 7, all of those have to be factored, so you're going to have to factor 4 different things and see what cancels. 2k squared plus 3k minus 2. I'm going to factor that into, this is 2k minus 1 and k plus 2 over 6k squared plus 7k plus 2. It's going to be, I think, 3k plus 2 and 2k plus 1 times, over here on the right, 4k squared minus 5k plus 1. It's 4k minus 1, k minus 1. K squared plus k minus 2 is k plus 2 and k minus 1. You can check all of those, but I'm just going to get the factoring out of the way. You can use your strategies from last chapter for factoring if you need to, the AC method. So let's look at what we can clean up here. Okay, so far I see, looks like, at least from what I see, k minus 1 over k minus 1 cancels. I also see k plus 2 divided by k plus 2 should cancel. So I should be able to just multiply out here. I don't see anything else that cancels if I did this correctly, which I think I did. So what do we have left? We've got 2k minus 1 times 4k minus 1 over 3k plus 2 over 2k plus 1. And here we can multiply out and FOIL if we want to, again, clean it up. 8k squared minus 4k minus 2k plus 1 over, I don't know if I'll have you leave it in factor form or clean it up, just in case we'll multiply out. 6k squared, well, we already know what this one is, plus 7k plus 2, because those two were multiplied before and they didn't cancel. So in total, this is 8k squared minus 6k plus 1 over 6k squared plus 7k plus 2. And that's really all for 6.2. It's just multiplying and dividing, and we'll do more in the next video.